the next couple days, keep in mind we have a short week this week, so 3 days. So today and tomorrow we are going to look at piecewise defined functions, and then Wednesday we're just going to review the absolute value and the piecewise, so Friday and today. So that's kind of our game plan for the week. Isn't that exciting? Huh? It is. You guys gonna come to the fall showcase? You get to.
I get to it.
Choir
I
and
get to for
great
one
acts.
time.
What about the rest of you? Are you coming? You guys are so excited about it. Okay, so what's a piecewise function? You've seen them before. What are they?
A nightmare.
Yeah. Oh, I am offended.
We love you, not the math.
You will love it this time.
Love the artist, hate the art.
Okay, a piecewise function is defined differently on different parts of the domain. Hence, we get pieces. For this section, we do one thing. For the next section, we do something different. When we graph piecewise functions, what I am going to recommend is we make a T-chart for each piece. When you do that, you always have to plug in the endpoints. Regardless of if they have an equal to or not, we have to include those when we make our T-chart. If something doesn't have an equal to when we plug it in, what do you think we would do when we drew it on the graph? How do we show something isn't equal to? Open circle. So we'll still put them in, but we will use open circles when we graph them. So let's graph this piecewise function. It's 2x plus 4 if x is less than 1, and 4 minus x if x is greater than or equal to 1. So, we're going to start with this first piece. We will make our T-chart. The first number you have to plug in has to be the 1. Even though it doesn't have an equal to, it says x's have to be smaller than 1. You can't give me the first number smaller than 1, because 0.9 is smaller than 1. And so is 0.99 and 0.999, and you could always get closer. So we have to put in 1 itself, but because it didn't have an equal to, that would be an open circle. So I always make myself a note when I do that. And then we need things smaller than 1. So maybe a 0 and a negative 1. Then, to get our y values, we plug those in to the equation. 2x plus 4. So 2 times 1 plus 4 2 times 0 plus 4, 2 times negative 1 plus 4. So 1, 6 is an open circle on my graph. That's the only open circle. Everything else is closed. So we have 0, 4, negative 1, 2. And it keeps going. It said x is less than 1. So that keeps extending off to the left, not to the right, because we don't want things bigger than 1. The next piece, we're going to do 4 minus x if x is greater than or equal to 1. So we need another t-chart for that piece. Again, we start with the endpoint, which is 1. But this time it's an equal to, so we don't have to worry about the open circle. And then we want things larger than 1. So maybe a 2 and a 3. So if we plug in 1, 4 minus 1 is 3. So 1, 3 is a closed circle on the graph. We put in a 2. 4 minus 2 is 2. Put in a 3. 4 minus 3 is 1. And this time it's going to the right because we were plugging in things bigger than 1. When you get to the end, this should always be a function. Okay? It should pass a vertical line test. If it does not, then you have made a mistake somewhere along the way. Probably. If I asked for it, what would the domain of this graph be?
What?
What's the domain of this graph?
Negative thing, positive thing.
Well, it stops at 1, but then the next one picks up, so it keeps going. So we eventually hit everything. The range,
Negative thing, positive 6.
right. So they're both coming from the bottom up, but the highest we get is 6, and that was an open circle, so it gets a parenthesis. So I could ask you to do domains and ranges from there. Let's try another one.
First time I accidentally wrote and then can use handouts.
So what's the first thing we have to plug in? 0. For plotting the first piece, we put in the 0. It has an equal to, so we don't have to worry about anything there. And then we want things less than 0. So maybe a negative 1, negative 2. You're looking at this statement right here to decide what numbers to plug in, whether it's things smaller or bigger than 0. So if I put them in, opposite of 0 is still 0, minus 2 is negative 2. Opposite of negative 1 would be a positive 1, minus 2 is negative 1. If I put in negative 2, opposite of negative 2 is 2, minus 2 is 0. So 0, negative 2 is a closed circle on my graph. Negative 1, negative 1, negative 2, 0, and remember, this started at 0 and it was for things less, so we're extending this graph on to the left. Keeps going there. second piece. What do we have to plug in first? Zero. Would it be open or closed? Open because it does not have an equal to. And then we need things bigger than 0. So maybe a 1 and a 2. You put in 0, 1/2 times 0 minus 2 is negative 2. If you put in a 1, we're going to get a decimal, which is fine. If you really are opposed to that, what could you plug in instead of doing 1 and 2? 2 and 4, if you don't want any fractions. Do you guys have a preference? Yeah. You don't like fractions. Okay, we will do 2 and 4 to make you happy. So 1/2 times 2 is 1, minus 2 is negative 1. 1/2 times 4 is 2, minus 2 is 0. Now 0, 2, we said it should be open, but I already have a closed there. Anytime you get an open and a closed at the same spot, you just leave it closed. Okay, don't try to put an open circle around it or anything like that. If one of the pieces fills it in, you just leave it as a closed circle. And then we have 2, negative 1, 4, 0. So this one's probably this way and kept going.
That's an absolute value function, but over function.
Yeah, kind of a little weird, but same general shape. Alright, well let's try another one. Oh no. So our function has 3 pieces this time.
I'll write that.
That's what I thought. Right there. Alright, so it's negative x plus 1 if x is between negative 3 and 1, 2 if x equals 1, and x squared if x is greater than 1. So the first ones, I'm not asking you to graph it quite yet. We're going to. But if I ask you to find f of 0, it's a function. So we know when we plug in 0, we can only get one answer out, correct? So we need to know which of the 3 pieces do I plug it into if I'm asking for f of 0?
2 if x is equal to 1.
Does
No.
0 is my x. Is 0 greater than 1? Nope, 0 isn't greater than 1. 0 is not equal to 1. Is 0 between negative 3 and 1? So that's the piece we plug it into. So you have the opposite of 0 plus 1, and we get 1. So I might ask you just to evaluate these by plugging in. So if I ask for f of 1, which piece are you plugging that into? It would be the second one. 2 if x equals 1. So if we put in 1, we just get out 2. If I said f of 2, which piece do you plug that into? 2 is greater than 1, so it would be the last piece, x squared. Do you guys see how I got those? To decide where we plugged it in, we had to figure out which piece the domain matched on. And then you put it into that part of the function. Before we do the domain and stuff, let's just go ahead and graph it. I think that would be easier. So for the first piece, what x values can I plug in? We're going to graph the first one, it has to be things between, we have to do -3 and 1 because those are both endpoints. And then probably something in between, so maybe -1. -3 had an equal to, so it would be closed, but 1 did not. So 1 would be an open circle. So if we put in -3, the opposite of -3 is 3, plus 1 is 4. If I put in -1, the opposite of -1 is 1, plus 1 is 2. If we put in a 1, opposite of 1 is -1, plus 1 is 0. So then we can graph -3, 4, -1, 2, and 1, 0 is open. Because this had 2 endpoints, it doesn't keep going in either direction. It's just in between those pieces. Next one. 2 of x equals 1. So the only x value we can put in is 1. And when we put in 1, we are going to get out 2. How would I graph that? It's just a single point. That's all that piece is giving. Final one. So I have to start with 1. And then we want things greater than that. 1 did not have an equal to, so that was open. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So 1, 1 is open. 2, 4. 3, 9. What is this piece? What shape are we getting? X squared, we should recognize that. What's it going to be? Yeah, it's like a quadratic, so we're getting part of a parabola here. Alright, so kind of a different looking graph. You should always verify at the end that it's a function. It has to pass the vertical line test. And it does, bless you, because we have 2 open circles here, so that's okay. What's the domain of this?
-3 to +infinity.
And what's the range?
0 to +infinity.
Alright, let's see what other questions I've got. Domain, graph the range. And last question. Is this continuous? No. We could give intervals where it's continuous, but the entire graph is not a continuous function because there is a break in the graph. Questions there? Let's look at one more. So if I said f of 0, which piece am I plugging that into? F of 0, so when x equals 0, we get out? No. 1. You get out 1 when x equals 0. F of 1. Okay, my 2 options, not equal to 0 and equal to 0. Is 1 equal to 0? Nope. So we're putting it into the not equal to 0 piece. So that's 2 times 1, which is 2. F of 2, which piece do you plug that into? not equal to 0. So 2 times 2 is 4. Alright, let's graph this and we'll do domain range from our graph. So we have two pieces. The first one, all it tells me is x cannot equal 0. We have to put in the 0, but what kind of circle would that be? If it's not equal to, it's open. And then we need I'll do something bigger and something smaller. So if I put in -1, 2 times -1 is -2. Put in a 0, 2 times 0 is 0. Put in a 1, 2 times 1 is 2. So -1, -2 is a point. 0, 0 is open. 1, 2 is a point. And this keeps going both directions. So what we're getting is a line that has an open circle in the middle. The second piece was 0 or 1 if x equals 0. So the only thing we can put in is 0. What we get out is a 1. So our graph looks like this. It's a line with an open circle and then just a point.
That might just decide to take a trip.
Mm-hmm.
Is there anything that's
I was like the line that it opens.
Domain.
the infinity, positive infinity?
What would be my range?
Negative infinity to 0 and then 2.
Right. We never actually hit that 0, so that is our breaking point. Is this continuous? No. How are we doing with graphing these? Do we need more graphing examples? You have been graphing for a while.
Sparrows.
Oh, okay, I want to do one last slide then for today. So this one I'm not asking you to graph, I'm just asking you to evaluate each of these. So I want you to take a minute on your own and try. So f of 0, which piece do we plug 0 into? 0 is greater than -2. So we get -1. F of -2.1. Where would I put in -2.1? Third. -2.1 is less than -2. So we put it in there. So 6 minus 3 times -2.1. And you get 12.3. C, -2. Which piece do we plug that into? The middle. -2 is equal to -2. So we have a -2 squared, which is 4. And 3. Which one do we plug that into? The first. 3 is greater than -2. So we get 6 minus 1, which is 5. Do we need more practice with any of this? So I have a handout for you and time to work so you can ask me questions. And we will continue this section tomorrow, wrap it up, and remember Wednesday we are reviewing.